Hi there! When assembling electronic circuits, it's usually better to use a PCB rather than a simple perf board. The PCB is better from different perspectives. It is more reliable because you do the design of all the connections up front, and you can check them several times before developing the board. Most of the time, you can rely on automated tools to do the PCB design, so there is less chances for errors. And also it is easier and faster to solder all the components to the PCB rather than using a perf board where you have to assemble all the connections to the various components one by one. So today I'm proposing you a way to make very cheap PCBs for your projects, PCBs that you can make at home with just a few materials that are easy to get, either at your local electronics components store or online, depending on where you live. Simple and cheap PCBs are fast to make and still very efficient in what they are supposed to do. Before starting, allow me to remind you to subscribe to this channel if you haven't done so already. Clicking on the subscribe button and the subsequent bell will allow you to be informed for free of every new video that I will publish in the future. So let's begin now. Let's start with a list of materials that you will need to make a PCB at home. There are 4 main items that you will need. The first item is a solution of ferric chloride, which is a chemical that is capable of dissolving the copper. Manage it carefully, always keep the bottle well closed, wear gloves when you handle the liquid and avoid splashing it because it is able to slowly corrode a vast range of materials and it will also permanently stain any type of organic material. Keep it away from your eyes and from your skin. And if you happen to touch it directly, promptly wash it away with a lot of cold water. Do not use warm water as it tends to accelerate the chemical process caused by this solution. Do not put it in your mouth because it is really poisonous. The second item is a PCB pen, which draws a track made of black or red ink that is similar to the enamel used to paint fingernails. As an alternative, you could use the actual fingernails enamel, but the pen allows you to draw better and thinner lines. The third item is of course a virgin PCB board that will become your actual PCB. And finally, the fourth item is an enamel solvent. You can use something like this one in the picture, but you can also use acetone or any other nail polishing liquid. They all work well, and of course manage with care these liquids as they are all flammable and poisonous. You draw the circuit first on paper by placing all the pads where the components are supposed to be soldered. Then, following the schematic, you start connecting the appropriate pads to each other. If you cannot connect directly 2 pads together, you can try drawing the connection going around other pads or other connections that have been made already. If you cannot find a path to make that electrical connection without crossing another one, you have 2 alternatives. The first one is to rearrange the position of the components so that it is possible to draw all the paths without any crossing. This of course may require several attempts depending on the complexity of the circuit. Note that I recommend this whole procedure only for simple circuits. When you have to work with complex circuits, it is always better to use some sort of software that can draw the schematic and is also capable of automatically creating the PCB design out of the schematic. Another thing to remember is to draw the connections with a thickness that depends on the amount of current that is supposed to flow through it. For low currents, the thickness of the pen itself is enough, of course, but for greater currents, use the pen to thicken the path yourself. In this picture, you can notice that some of the paths have been designed to be thickened that way. Before transferring the PCB traces on the virgin board, we need to clean it so there is no copper oxide on it. A very fine sandpaper will help in doing so, after which you will have a shiny copper surface. Use some alcohol on a piece of paper towel to remove any residual dust from the copper surface, and do not touch the surface with your bare hands or the oxide will come back. Wearing gloves will help on that. Once the surface is clean, let the alcohol dry and then start copying your design onto the copper using the PCB pen. Again, starting with the pads, and once they are all drawn, add the traces to connect the appropriate pads. When you draw with the pen, make sure the larger surfaces are totally covered with ink, otherwise you will get an uneven copper surface when the PCB is done. You can also add symbols on the board, so later you will be able to identify the location of each component environment more easily. If you make a mistake, use a cotton swab with some solvent to remove the wrong part, then let the copper dry, and then start drawing again. Double check everything to make sure there are no errors. Once you move to the next step, you won't be able to fix them, so find the errors and fix them now. Once you have drawn everything you need, let the ink dry for about 1 hour. The process for which the unwanted copper is removed from the virgin board is called etching. We do that using a chemical solution called ferric chloride. We start with a small plastic container, big enough to contain the board that we need to etch, and tall enough so the solution will not spill over. We shake the ferric chloride bottle to make sure it is uniform, then we put some ferric chloride in the plastic container, enough to cover the board once immersed into it. Then we immerse the board, copper up, and we let it stay there for a while, shaking the solution and moving the board from time to time, so the copper dissolved from the board does not lay on the board itself, but instead spreads around in the liquid. Notice how as soon as the board is immersed in the solution, the copper starts changing color. A little bit at a time, the copper gets dissolved into the solution, first at the borders of the board, and then deeper and deeper. While this happens, you will notice that the solution changes color, becoming darker and darker. That is the sign that the copper is dissolving from the board into the solution. The copper covered with the ink is protected and does not dissolve. Once the etching process is completed, we remove the board from the container and we wash it under plenty of water. Use a lot of water. You need to make sure that all the solution is gone from the board, otherwise the corrosion of the copper may continue later. Now the enamel can be removed from the copper using a rag and some solvent. Do not dispose the whole residual solution in the container, you can reuse that in the future while adding some more fresh solution to accelerate the etching process. Once you collect a certain amount of used solution and you need to get rid of it, collect it into a plastic bottle and give it to your waste company. Separate from other waste. They will treat it in a special way without releasing all that copper and iron directly into the environment. Once the board is clean and dry, clean it again with some alcohol and don't touch it anymore with your bare hands to prevent the copper from oxidation. Next step is now to drill the holes for the components, if you will be using pass-through components. But if you will be using surface mount components, then you can skip this step. After drilling, clear the board with alcohol one more time. To help preserving the copper, you should buy some of those paints that are used exactly for this purpose. Or you could do what I am about to, as a cheaper way to obtain the same result. Yes, you see it right, I spread a thin layer of solder on all the copper that is left on the board. The solder prevents the copper from oxidation and will also help solder the components on it. Now the board is ready to assemble the circuit. Today we have seen how to design and etch a PCB that can then be used to assemble an electric circuit. Once again, since the procedure involves the use of chemicals, go through the whole process as safely as you can. Better safe than sorry. So this concludes today's video. Thank you for watching it and please give it a thumb up, which will help improving its visibility so other people can enjoy it too. Once again, if you haven't done so already, please subscribe so you can be automatically notified of new videos. And finally, a small monetary contribution will also help in making more and better videos for your enjoyment. Details are in the description below. See you on the next video and as usual, happy experiments!